Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome back to my lecture. So today we are going to discuss about uncertainty, choice and risk. We already began our discussion. So to continue further, so we'll talk about choice, uncertainty and risk much more in details. So in our previous lecture, we already discussed about risk, and also we tried to calculate value, expected value and also expected utility that are associated with the commodities or anything that we are trying to derive utility, which is probabilistic, and therefore from those events that has probability, so from there we also try to calculate, and also we had shown that how to calculate expected value, and from there we also try to calculate how to get the expected utility. So utility is very important, and in our consumer behavior discussions, although we did not discuss much more in details, but then in optimization discussion we spoke about marginal utility, total utility and also the optimization conditions, where indifference curve is tangent to the budget line, and budget line, the way we perceived in our previous lecture, budget line is considered as a resource, even in context of public policy. So budget line is the resource constraint, and then utility is basically how much utility that from that particular policy or from particular commodity. If we are considering public policy as a commodity, then how much we are getting it, and then what is the optimization conditions. So these are the things that we already discussed. So today we'll talk about risk aversion, then marginal utility and then premium. So in context of risk, we introduce 3 points, and then the fourth point, which is like how to deal with it and how market can actually enter in this risk business. So in the risk, there are 3 points that we discussed. One is risk aversion, the other one is risk neutral, and the third one is risk loving. So in other words, if I put it in other way, like risk aversion, and then it's opposite to this, like risk loving. So some people or say one person, for two alternatives, or if he or she has two options, then we'll first calculate what is the expected value from option A and option B, and then from there that person will decide whether to go ahead with the risk or whether to avoid or minimize the risk as much as possible. And then the third point, that in between risk aversion and risk loving, is like risk neutral, is like indifferent to choose anything. And there we said that this risk, calculating risk, of course we can calculate, one can calculate from expected value, but then we can also calculate from utilities point of view. So let us spend a bit more time here, because we said that we will not discuss much more in details, but then we should not lose out any technical details that are important in this particular discussions. So just to reflect, like say we already calculated expected value of the x, and this is nothing, is basically summation of value of p and x. P is the probability of x, and then x is the event. So every event has the probability, like say x1, x2 and then xn. So I'm just iterating once again. So probability associated to x1 is p1, and then probability associated with x2 is p2, likewise pn for xn, and then here I equals to 1 to n. So this is how expected value, that This is how we calculate expected value of x. So similarly, we also calculated expected utility, right? So expected utility the similar way, it's like u xi uxi, so basically this is a summation that we already discussed about this. So this expected utility also has the probability, so pi. So this is what we did talk about expected value of x and expected utility that we get it from there. So now what is utility? So total utility, from total utility, for instance, we are deriving from say x1, x2 and xn. So marginal utility for this is like we'll get individual marginal utility, like mu1 we'll get from x1, marginal utility 2 will get it from x2, then we will get marginal utility n from xn. So this is what we call that utility and marginal utility. So changes in the total utility due to one unit changes in one commodity, and here in case of mu1 is nothing, changes in the total utility due to one unit change in x1. That's how mu1, like marginal utility 1, is getting defined. So now we know that utility has diminishing returns assumptions. So which means, so here if along with the vertical axis, if it is utility, total utility and quantity of x1, if we measure along with the horizontal axis, so marginal utility suggests as quantity increases, then your total utility will increase first at the increasing rate and then decreasing rate, but then it will reach at maximum and then started slowly started falling down. So this is what total utilities assumption. So total utility will start falling as we start consuming more and more about that particular commodity. So marginal utility is basically diminishing. So with this, by the similar logic, like if we consider mu here and then x1, so as total utility is decreasing, so marginal utility, like changes in the total utility, like for every count here, like the change that we are seeing in the total utility, that we see is a diminishing, and that's how marginal utility will start falling. So this is how marginal utility, what we call diminishing returns, and following law of diminishing returns. And this is just to kind of revisit our earlier discussion, because we need these assumptions while explaining risk aversion, marginal utility, which is diminishing, and then premium. Let us move forward and let us understand risk behavior, especially risk aversion, risk loving and marginal utility together, and also try to understand how and when premium is getting calculated. So we already tried to understand that utility or risk is getting calculated with the expected value. It could be expected value of any events or expected utility. So imagine there is a person, individual, and has two options for the job, and from two options or two job options, earning levels, it varies. So option A is little less risky or no risk associated with, say, option A, like from job A, and job B is having some sort of risk. And then if you are risk loving, then if you want to take, then your value or earning will get variations, like either you will get more or you will get zero. So let us take that example and then proceed further. Like say option A, we have like say $70 per hour consultancy, for instance, that we get. And then option B, there is a 70% chance, if you take risk, that particular job that has a risk associated with that. So 70% of chance or the risk that you will get, of risk that you have, that you will get $100 per hour, and at the same time there is a 30% risk that is associated with this particular job, that you might get 0, means none, no dollar at all. So of course the option A is having no risk, and there is a certain level of assurance from job A that we are getting it, and that is $70 per hour. It's a very highly skilled freelancing, for instance, one can assume. And option B is like again very high paid per hour hourly work that you are that say one of the Indian is working for a global company. So but then there is a risk associated with it. So if you want to get higher, like for instance, there is a definite that you will get maximum, you will get $100. There is a 70% chance that you can get maximum up to $100. But then there is another one chance that you may get 0, nothing, because this particular job has some risk associated with it. Then definitely $100 per hour is certainly higher than $70 per hour, like $30 extra, which is quite substantial earning differential. On the other hand, at the loss of entire earning, like I will not earn anything. So of course option B, the person, if the person chooses like option B is like risk loving person, and option A is basically risk averse person. So how one can actually calculate? So let's calculate from the expected value, and then we can like say expected value for option A is very clear that we are getting it $70, very definite. So the moment probability associated with option B, then we have to calculate expected value for B, not for A. We don't need to worry about A because it's very clear that we are getting 70. So expected value for B is probability of the first occurrence, like which is $100, like $100 will be treated as or can be viewed as x1, and then it has probability which is 70%, which is 0.7, then plus the other, like other extreme, means 0 multiplied by 0.30. So it's basically x1 p1. So if you recollect, and this one p1 is like probability, and then this is the product, the value of x1, the expected value of the x1, and here is like x2 and p2, which is value of x2. So if we sum it up, so this is coming from sum of p1 x1 plus p2 x2. So there we are getting 70. So from this calculation, like expected value for option B is 70. So now there are three possibilities. So either you choose A, option A. So option A. Then you have option B. Then you have option A or option B. In this particular example, why we are giving this, like you see the expected or value of value of option A is 70, expected value of option B is 70. So those who are risk averse person, like especially most of us, that we are supposed to be risk averse because one of the major principles of economics is like from the rationality's point of view. So those who are risk averse person will choose or will go ahead with option A because option A and option B are giving equal, right, 70. So then option B, the people, some fraction of the population or the group will go ahead with option B because option B is giving, there is a chance that you may also get $100. But then from expected values point of view, it's a neutral. So option A and option between option A and option B, it is also in terms of value, it is neutral. So for neutral person, one segment or one group will be indifferent to choose between A and B. So for them, total outcome is 70. Either can get from option A or from option B. But then risk aversion, general tendency is to averse the risk, and therefore people will go or any group will go ahead with option A. So that is the first rationality. But then risk loving person or the people who can take some kind of chance, like for instance with the stock market, so people will go with the hope that they might get 100. So it is always towards the positive side. Nobody will count the zero, that occurrence that you might also completely lose it. So people will always try to go ahead with the highest maximum possibility or probability of the highest occurrence, like $100. So here certainly the choice between option 1, option B, option A, option B, or option A or B, like indifferent between A and B. So it's a very clear, it's like majority of the population or the group who are actually doing this option, choosing these two between these two alternatives, like alternative A and B. So economic rationality says that you should go ahead with option A. So that is what the first point, that we have to calculate expected value of the options which has risk and which has the probability of each of the occurrence, right? So now further, like option A is absolutely clear risk aversion case, and option B is clearly the case of risk loving, right? And then either option A and option B, it is basically the neutral. So now this has the utility, right, and diminishing utility. So let us also understand what kind of utility that we are getting it from this particular case. So now suppose the utility function, say utility function here is, like say u is the square root of say m, and then what would be the first step? First step is we have to calculate expected utility, right? And then we also have to calculate expected value, especially for the option B, right? So expected, what is the expected utility? Expected utility for B, option B, because that is very important. And here the probability is 7 for the first occurrence, where utility is defined as 100. So square root of 100 plus 0.3, which is the second probability for the other extreme occurrence, like I may lose it completely, and then it's like outcome is say 0, and 100 is the maximum occurrence, and then here we get 7, like here square root of 100 is 10, 10 multiplied by 0.7 is 7 and then plus 0. So this is our expected utility for the option B, right? So now what is the total utility? So this is expected utility. So total utility, for instance, in this particular case, so utility is U is equals to 70, that the utility that we get, 70 is like definite income, like $70, like say from option A. So we can actually say that from option A, which states definite value of that particular job, and that is 70, and then square root of 70 is 8.367, right? So this is what the utility. So now once we plot this, so how we get it? So let us discuss further with the help of this graphical representations. And here assume that 70 is basically the earning. So on the horizontal axis, it is basically earning that one can say, and then here is utility. Utility is measured along with the vertical axis. So now there are different like utility curve, like total utility curve that we are talking about, and total utility curve following diminishing marginal utilities assumptions. It is this, like this is total utility curve, and then maximum wealth that I can get it from this particular options, like following option A and option B, maximum outcome that a person has in front of that particular person, like particular individual, is 100. So if 100 is the maximum profit or maximum earning that can per hourly earning that individual can earn, and that is from option B. So this is option, like say this is say maximum utility, so like say $100 per hour, and across $100, so if I have $100, so with $100 utility will be given this utility function, like say equation 1 we can actually refer here, which is utility function, which is referred as square root of m. M is the value. So here with 100, so total utility will be 10. So we can actually show this here. So we can plot this and we can see corresponding to this 100 earnings, utility, like say U is actually 10 units, like that is the utility that I am deriving from 100 earnings. So now here there are a couple of points. So now with the expected utility, like say option B, if I am going ahead with option B, or say if I am going ahead with option A, so option A is very clearly stating here, like utility is 8.367. So if I want to earn 70 without any risk, so 70 is here, like say we can say that 70 here, and then along with this 70, utility is utility with 70, like say we can say utility 1, here 2 is 8.367. So now interesting point here, so this is the utility, but we also have to understand the risk, right? So now let's talk about option B. So option B is clearly stating that it has the risk, and then at point 0 is a 0 risk, and here, so that is, we can calculate the risk along with the straight line, and here say O to say A here. So we can see here clearly with the $70, with option A, I'm getting 8.367 utility. So now see here, expected utility from option B is 7, right? So expected utility here with the 70, so it's basically so here expected utility, which is 7, right, at this point. So the difference between these two utility, or the risk that we are actually saying, is between utility 8.367 and utility 7. So here we can say that we get a point, say C, and here D, and here say E. So with the expected utility of 7, or when utility is 7, then what is the earning status? So we can say here, when utility, let's say when utility U equals to 7 equals to say M is the say earning, so it's basically state that M will be equals to 49. So here the square of 7 and square of square roots, and that's how we get it. So M is of course the earning. So with this 7 utility we get $49 per hour earning, right? So with the 70 we have definite, without any risk, we can get our utility is 8.367. With 70 our expected utility, if I am taking risk, it is 7, but then with 7 utility, with the expected utility, earning is 49. So now here two things. So risk is coming. So what is the risk amount? Risk amount is between the 2 points C and D. So what is the D point? D is utility curve, precisely with a certain outcome, and then OA line represents utility, like say expected utility with risk, or we can simply call it, to keep it simple, we can simply call it just utility of with risk. So it's basically this point C to D amount is the risk amount that we are talking about. So now coming to the third point on the premium. So you see here with the risk is basically 70, but then there is a gap between C and D, like with actual utility that we are deriving and utility with the risk. But then if you are going ahead with the expected utility, then our actual earning might be $49. So now when we talk about premium is basically the amount between C and E, which needs to be covered by the company, insurance company, and here we can say that point point between E and C is the premium. We can call it risk premium, right? So this amount. So what would be the risk premium? This is like 70 risk premium is equals to 70 minus 49, which is 29, 21. So 21 needs to be covered by the insurance company. So when insurance company comes, insurance company will look into the risk, how much risk that one has. So if risk amount, like if area between C and D, if that difference is very high, so that means very high risk, and therefore risk premium also will be high, because people will generally, when there will be claim, then also there will be huge amount of claim will be coming, and therefore risk premium also will be very high. So in this particular case, if we consider that, so in this particular graphical representations, and also with this case like $70, and then with the 70% of the risk and 30% of the risk of the losing entire amount. So with the option A and B, one can also imagine from say business point of view, or especially from the startup point of view, and you choose the area that you want to start the venture. So one, you can see like $70 per day profit. For instance, if you want to set up any startup in the urban areas, or you want to do it in the say in the rural areas, if it is tourism related activities like say homestay and all. So if it is like little far away, and then but then if you get the customer, and which is the probability is 70%, if you get it, then you will get your earning will be, or profit will be $100 per day. But then if they don't come, like if tourism or some risk associated with say some pandemic, or they lost it, the entire business, so in that case the entire loss, like 30%, there is a 30% chance that one person can lose it. So in that particular case also one can actually calculate like how we calculate expected value and what is the risk associated with it, and then from the utility we can clearly get it the amount of risk utility risk that are coming from utility, actual utility and also expected utility, or say utility from the risk. And then also we know that how to calculate risk premium, which individual also will remember, like while whether to buy that particular insurance or not. So it could also be cases for health insurance. If premium is very high, that means when you fall sick, when one falls sick, then definitely the return that that person will get will be also very high, but then premium also very high. So person will tend to not to take risk, and therefore risk averse aversion, or a risk averse person will try to avoid that and then will buy with will go ahead with the insurance even if it is high. And some people will say that okay, I just don't want to take I don't want to buy this, and then I want to take a risk, and then how to calculate risk and how to take a business or earning with risk or without risk. So I'll stop here and then we'll discuss further, because there is a continuation of this, because we only spoke about risk aversion, but then how risk loving persons, their premium and then their outcome looks like, and how indifference curves looks like when risk loving person. So generally in economics we don't much care about the risk aversion people, because it is with the definite outcome. So a lot of calculation happens when risk loving or outcome that has, or investment that has risk, like for instance stock market or any sort of any investment that has the risk associated with it. So in that particular context we generally try to understand more and more in details about choice and technique, and also the options that we get it, like optimization. So I'll stop here. For further more examples, or for going further or much more in details with much more other examples from different countries, you can go ahead with this 3 references that I have followed. So thank you very much for your attentions, and I'll see you in my next class, which will be the continuation of this particular lecture.